Welcome to the BNM1 lectures. In today's class, I'll be starting the unit number 3. The contents are design of riveted, welded, and bolted or screwed joints. In the riveted joints, first we will discuss the types of riveted joints, modes of failures, efficiency of a riveted joint, design of riveted joints for a boiler shell. And in the welded joints, types of welded joints, the strength of the parallel fillet weld and strength of the transverse fillet welds, axially loaded unsymmetrical welded joints. In the bolted joints, stresses in the bolts due to initial tightening, external loading, combined loading, eccentrically loaded bolted joints in shear, and eccentric load perpendicular to the axis of the. Now let us move to the details. Introduction to the riveted joints. A rivet is a short cylindrical bar with a head integral to it. This is the head, and this is the shank portion, or it is also known as the body. The end portion is known as a tail. You can see here. So this rivet is introduced into the holes drilled into the plates, and this tail portion is transformed into the head portion, similar to the head portion, by using the punch and die method. The rivets are used for permanent fastening between the plates. The permanent or temporary, it depends upon if you want to separate the two plates which are joined by a riveting process, then you need to destroy uh, the rivet head. So after destroying the formed rivet head, either at the bottom or already uh, the head which is there before the rivet joining, that should be destroyed. So after destroying rivet head on one side, you can remove the rivet from the two plates, and then the two plates can be separated. So permanent joint means in order to separate the two things which are joined, some amount of destruction should be done. That is called the permanent fastening or permanent joint. Whereas the temporary fastening or temporary joint is the one uh, which can be assembled or disassembled at ease by using a screwdriver or by using a wrench or something like that. The examples are screw joints, keys, cutters, splines, etc. These are called temporary fastenings. So the temporary fastenings can be uh, disassembled without destroying the components. That is temporary, the meaning. The applications of riveted joints. You can see here a structural work. This is a bridge. So the bridge is constructed uh, by riveted joints. The plates are joined together with the help of rivets. So here also you can see uh, number of rivets here, and in the railway construction, railway bridge works, and here a boiler shell. In the boiler shell also, this is the circumferential joint to make the required length, and this is the longitudinal joint to make the required diameter. So these are the various applications of the riveted joints, and also they are used in the ship construction, and in the plane construction also the riveted joints are used. Types of riveted joints. Generally, there are two types of riveted joints. One is a lap joint, another is butt joint. In the lap joint, the two plates which are to be joined are placed one over the another like this, and a through hole is drilled, and through which the rivet is placed or positioned, and at the tail, with the help of the punch. and die, the rivet head is going to form. By the way, the two plates are joined permanently. So here in the lap joint, there are again depending upon the arrangement of the rivets, they can be single riveted or double riveted. Single riveted means there is one row of rivets, and double riveted means there are two rows of rivets. And there can be another type of arrangement of the rivets. That means the two rows which are the rivets in the two adjacent rows are not in the same line. So here they are in the same line. This can be called as a chain riveting joint. Whereas here, even though there are two rows, the adjacent uh, rivets in the two rows are not in the same line. They are uh, zigzag mannered. So that's why this joint is known as a zigzag riveting joint. Next, in the butt joint means the two plates are to be joint placed like this. They are placed in this manner, parallel to each other, touching. The two plates are touching each other, and the cover plate is placed on one side or on both the sides. So if a cover plate is placed here on one side, that is single cover or single strap. If it is placed on both the sides, then it is called double cover or double strap butt joint. Here you can see a single riveted and double strap butt joint, and here you can see double cover and double strap butt joint with the chain riveting, and here you can see the double strap or double cover with the zigzag riveting. Various important terms in the riveted joint. Pitch is the distance between centers of the two successive rivets in the same row. Pitch is the distance between the centers of the two rivets in the same row. Back pitch. This is the distance between the centers of the two rivets in the adjacent rows. And diagonal pitch. This is in the zigzag riveted joint. And this is the distance between two rivets. They are placed in the adjacent rows. This is inclined and this is horizontal and this is vertical. M or marginal pitch is the distance of the edge of the plate to the nearest rivet's center. It is the distance between the center of a rivet hole to the nearest edge. That is called margin. Margin is generally taken as 1.5 diameter, where D is the diameter of the rivet hole. Types of failures or modes of failures. A riveted joint can fail in three different modes. One is the tearing. So from the nearest edge to the uh, center of the hole, there can be a tearing takes place in this manner, and along the rivets also the tearing can take place like this. So tearing from the edge of the plate and tearing of the plate across a row of rivets. So these are the two ways of tearing failure. The tearing area is it is calculated per pitch length. So P is the pitch length and D is the diameter of the hole. So for pitch length, the resting area is P minus D into thickness of the plate. Next, shearing of the rivets. This is second mode of failure. So when the plates are joined like this and they are being pulled away, they are displacing the rivet shank like this. So the upper portion is moving towards left and lower portion is moving to the right. The resistance applied at the junction, that is the area of the rivet's cross section, will be the resting area. So when We have a lap joint. This is a single shear. When you have a butt joint with single cover plate, again you will have a single shear. And when you have double cover plates, then there are two places where the shearing takes place. This is called double shear of a single rivet. So now the shearing area for single shear is diameter of the rivet d, so it is 5 by 4 d square. In the double shear, it is 2 into 5 by 4 d square. According to the Boyle's regulation IBR, the double shear, instead of taking it as 2, it is taken as 1.875 into 5 by 4 d square. Shearing resistance or pull required to shear off the rivets for pitch length is taken as n into pi by 4 d square into tau. So whereas n is the shearing resistance or the pull required to shear off the rivets for pitch length. In a single shear, it is pi by 4 d square into tau, and n is the number of rivets per pitch length. In the double shear, theoretically, the earlier one is multiplied by 2, and according to Boyle's regulation act, it is multiplied with 1.875 instead of 2. So n into 1.875 into 540 is equal to, where n is the number of rivets for the pitch length, and 1.875 is the factor for the double shear according to the Boyle regulation act. 540 square is the area of the rivet in single shear, and tau is the allowable shear stress. And third one is the crushing of the plate or rivet. The crushing of the plate or rivet. When two plates are joined together with a rivet, either the plate or the rivet's shank may get crushed due to the pull applied on the plates due to the internal pressure or something else. The weaker of the two or the softer of the two may gets enlarged. Either the hole gets enlarged or the diameter of the shank of the rivet gets compressed. So due to this, the leakage of the fluid which is inside, let us say if this is made for a boiler shell, in the boiler we used to store steam. That steam can easily escape through this gap. So then, even though the separation is not going to take place, but still the purpose of the joint is gets defeated. Hence, we treat it as a failure of the joint. The crushing of the rivet or plate is also a failure, even though physically they are not going to destroy or get separated. Here, the resting area is taken as the diameter of the rivet and the plates in which the rivet is placed. So that is called the projected area. N is the number of rivets for pitch length. So N into D into T is the crushing area. When it is multiplied by the crushing strength or sigma C, it gives the pull required to crush the rivet per pitch length. So we have total three modes of failures. One is the tearing, another is shearing, and third one is crushing. The least value of these three is taken as the strength of the joint. Strength of the riveted joint is least value of the three: the crushing resistance, shearing resistance, or tearing resistance. Three are taken. Out of these three, the least value is taken as strength of the joint. The efficiency, the efficiency of a riveted joint is strength of the riveted joint divided by strength of the unhold plate. The least value of shearing, tearing, and crushing is taken as strength, that is in the numerator. In the denominator, it is the strength of the unriveted or unhold plate. So, width of the plate into thickness of the plate into the tearing strength. So, the tensile strength here. So the tensile stress allowable multiplied by the thickness multiplied by the pitch length, or for smaller things we may take the width. So the width or pitch multiplied by the thickness multiplied by the allowable tensile stress. That gives the denominator, that is the strength of the unriveted or unhold plate. So with this numerator and denominator, we will find out the efficiency of the riveted joint. Let us take a problem here. Find the efficiency of the following riveted joints. Single riveted lap joint 6 mm plates with 20 mm diameter rivets having a pitch of 50 mm. Double riveted lap joint for the same with a pitch of 65 mm. The allowable stresses are given as 120 MPa in tension, 90 MPa in shearing, 180 MPa in crushing.